A ball is projected upwards at u-meter per second. Ignore the air resistance, then the only force exerted on the ball is weight. According to Newton's second law of motion, W is ma. And since W is mg, the ball's acceleration is always g, regardless of its mass. The ball's motion has a rising part and a falling part. In the rising part, the velocity and the acceleration are opposite direction, so the ball goes up to the top position where velocity is 0. And then goes down. When it passes the position where it was projected, the velocity is also u, but pointing downwards. Suppose u is 10. Using the formula, v equals u plus at, and a is minus g, the time it takes to go to the top position is 1 second. Using v squared is u squared plus 2as, and v is 0, the distance from where the ball is projected to where it reaches the top position is 5 meters. In general, when solving this kind of problems, you set a positive direction, and use the correct sign for all values. For example, find the velocity when the ball falls 1 meter below the start position. We make the upward direction the positive direction. Then u is 10. A is minus g. S is minus 1, because it's below the start position. Using v squared equals u squared plus 2as, we get v squared as 120. We know v points downwards, therefore, v is minus 11.0 meters per second. Be sure to put the correct sign for each value. Pay extra caution when you are asked to calculate the distance, because in all 5 formula, s is displacement. For example, if you are asked to calculate the distance the ball travels before it hits the ground, then you'll have to calculate both the rising part and the falling part. A ball is projected upwards at 6 meters per second. After it reaches the top position, it falls for 2 seconds. Find the total distance it travels. This question asks for distance, not displacement. So we need to consider both parts. For the rising part, u is 6, v is 0, a is minus g. Using v squared equals u squared plus 2as, we get, s is 1.8 meters. For the falling part, u is 0, a is g, t is 2. Using s equals ut plus half at squared, we get, s is 20 meters. So total distance is 21.8 meters. Find the time it takes the ball to reach 1 meter above the starting position. We know there are 2 instants when the ball is 1 meter above, one when it's rising, and the other when it's falling. In either case, the displacement is 1 meter. U is 6. A is minus g. Using s equals ut plus half at squared, we get, 1 equals 6t minus 5t squared. It is, 5t squared minus 6t plus 1 equals 0. Factorize it, we get, t minus 1 times 5t minus 1 equals 0. So t is either 0.2, or 1 second. We know it takes 0.6 seconds to reach the top. Therefore, one instant is during rising and the other instant is during falling.